Hey YouTuber, today I will show you how to use this software that I wrote to communicate with the source measurement unit Keithley 2450. Let me start the program while I'm talking so that it's not so boring. Okay, now I need to change the current range a bit bigger. So here I have just a LED diode, and you will see the characteristic of the diode as we do the measurement. Let's clear the graph so that you will see it better. So the source measurement unit are beautiful devices. However, in order to use it, some programming skills are required, and this is not so convenient for many people. For example, my program, I need to write around 1000 lines of Python code, which is not so many people want to do it if they are not in the field, or maybe they are biologists or chemists, which is don't spend a lot of time to write to do programming. So this device, Keithley 2450, has even graphic user interface. However, for my use purposes, it is limited. I can continue doing the second time. Especially by data recording and transferring. Other source measurement unit does not even have a graphics user interface, so there is no way you have to program it in order to use it. So that's why I wrote this program so that it would do everything that I wanted, and I want to show you how to use this, and maybe you want to use it too. So in order to use this program, you need a Keithley 2450. It might work also for 2400. However, you might see some notification of error because the command sets are not totally compatible. So at first you have the Keithley 2450. You need to change the command set of the device to SCPI because I use SCPI's command set. So let me stop it here and show you how to change it. Here I have Keithley 2450. I go to menu, and in the setting you can change command set to SCPI. I already changed it, so I don't need to do it. Program communicate with the source measurement unit via a GPIB card. So in order to use the software, you also need a GPIB card and a computer, of course. So in order to use this GPIB card, we need to install the driver for it. For my case, it is a Keysight GPIB, so I need to search Keysight IO libraries suite. You go to the website. Okay, so you just go and download IOLS, the newest version, and yeah, it will run. It will take a while. So it go to here, you just click next. Do you agree? I do. So it will ask you to install the Keysight Visa as the second visa. You just click OK, and just typical is enough, and install. And it will take some time. So the installation was done. You just go to Keysight Connection Expert, and you don't have nothing because I didn't connect the device to the computer, so I will connect the USB GPIB to the computer. I don't see nothing. It takes some time to initialize the GPIB connection. Yeah, so you will see that it is source measurement unit 2450, and this is the address. And this address you probably should remember. So if you go to the link, you will see a free version of the software. You just download it and you can install it. Yeah, so at first you can select German or English, and you can just click OK and next, next, next. And I already installed it so that I don't need to do it anymore. So you go to the software. So at first it will tell you that I am loading some library, and now you see that the software detected which connection, GPIB connection, that it sees, and then you can just, if you, in the case you have several devices that connected, then you should select the one that you want to use. In my case, it's only one, so I select only one. The terminal, you can use the front or rear terminal. The rear terminal is for more precise measurement, and PLC is the number of integration cycles. It is a typical parameter of Keithley, so you can select different accuracies of your measurement. The more accurate you want to measure, the longer time it will take. Measurement mode, you can measure in IV curve or in real time. So here you have to, the measurement mode is here. You can change it here, the tab, but it doesn't affect the measurement mode. You have to change it here, and it will reflect here in the tab. For example, here in IV, the source delay time is a time that the Keithley will wait after you apply the voltage. So it depends on how capacitive your device under test is. You should set different delay time. This is like a RC circuit. So the default is, I think, under 3 milliseconds. So for some device that I did experiments, I need to wait a bit longer in order to receive precise measurement. So you can select small or big, depends on your device. Voltage range is the range, maximum range that you can apply. You can apply, for example, from -2 to 3 volt, and the step is 0.1, and the current range is 100 milliampere. Here is where you can save the data, the file name. Here the graph, you can use it in linear, or let's just select linear and click start. So the program will shift from -2 to 3. So you can click tile layout so that you can see it a bit better. So the current is here in 10 picoampere range, and now we cannot see it anymore. So we probably want to change it to log. Oh, it's already over. So we want to do it one more time. So it will change the graph to logarithmic scale. Okay, so it will run this program. Sweep one more time. So I don't want to waste your time, so I stop the program. But you saw it here. In this range, the current is around 10 nanoampere, which is quite suspicious because the reverse current should be way smaller for this LED. So I select the smaller range, and I want to see it, yeah, maybe until 2. It's good. Then you will see how is a smaller current range will affect the accuracy of our measurement. As you see here, is in the range of 100 picoampere, which is, yeah, maybe the measurement limit, accuracy limit in the front panel of the Keithley. If you use the back, or if you use the rear panel terminal, probably you will receive a better result, and it is limited here, only 100 nanoampere. One more thing is that if you want to shift from positive to negative, you should change the step to the negative so that it will switch from right to left. But here I set 100 nano, so you will see it is in 100 nano. But you understand what I mean. I want to say, yeah. So you see it is sweeping from right to left. Okay. So another feature is that if you want to change it into the real-time measurement, so you have a voltage range, the voltage you want to apply, and the current range, and here you have a aperture is the time that it wait between two measurements. So this is, maybe I want to do 2 measurements per second around, and then I just click start. So you have here the real-time measurement. I just want to show you how the data look like. Okay, so you can just click stop, and you can click start again, so it will override the old program, and then you click stop, and maybe you want to change, the BIOS voltage a bit smaller to see how it is affecting your program, your device. Yeah, and you can see whatever you want. So how the data look like? So this is the data that was recorded during our measurement. So you can see this is the IV measurement. Let's see. So you can see one column is voltage, the other column is current, and in the real time you see it, yeah, one column is time, another column is a current. So if you like the free version, please go to the description and download it, and you try it and give me a feedback. Thank you. Tschüss und mach gut.